Hello, everyone. Today is Saturday, July 23rd, 2023. I'm here to serve you with Linux how-tos. In particular, I'm going to discuss shell scripting. Let's go through a slideshow, and we're going to do from the current slide so we don't have the other slides just repeated. We have covered slide 1 through 9 already. This is video number 10. And it is Linux how-to on shell scripting. I'm going to be discussing shell scripting on Ubuntu mostly, and also I'm going to cover Red Hat. The option that we are covering Ubuntu and Red Hat and many other shell scripting techniques that you're using are all the same, whether you use Ubuntu or Red Hat or CentOS or Rocky or OpenSUSE. The only list of commands that you're passing, sometimes it depends on the different distribution. For example, if you're using file manager or package manager, the commands that are available on Ubuntu is, let's say, apt cache, apt-get, all those commands that are available. And then on Red Hat side or Rocky side or CentOS side, there are DNF and YAM and RPMs. So I'm going to be discussing shell scripting, and the if statement, while statement, or all kind of for statement. All of them are used the same way that you use on all the platforms. So let's just go back to the web server. Actually, on my MyWebUniversity free educational videos that I had, I changed the title to MyWebUniversity, and now you're going to see this title, MyWebUniversity, and the same videos that I have posted are all available for you to do it. For example, this video is a full course on Red Hat Enterprise Linux 9, and there's a lot of advanced Linux, a lot of systemd, system CTL, most used commands. So please just subscribe and start learning on MyWebUniversity YouTube channel. If I go to the latest videos that I have posted, on the latest videos, as you can see, 22 hours ago on Saturday, I posted this Linux how-to on package manager for Ubuntu and Rocky and also Red Hat. So that is those sessions. And when now you're learning shell scripting, so the configuration of some of the script, how you build it in terms of writing a script depends on the OS version that you're using in terms of package management, if you have to do those ones. But let's get started with the actual VM. So I'm going to log in on the VM here. And in fact, when I log into the VM, I will show you that I have already SSH to my web server, which is this machine host name here. And I've already set up my environment to be this echo $sign PS1 is to be just short for that. So you could see that it is giving you the $sign prompt here. So clear screen here. Host name, it's MyWebUniversity.com, which is my production server on Linux Ubuntu. Cap etc OS-release. You can see it is Ubuntu 22.04 long-term support. So I'm going to just show you the demonstration of shell scripting on this platform. To do this, so I'll first clear my screen, do a pwd, and notice that I'm on that directory here. I'm going to go to my main directory and go to programs and then shells, and then inside here, if I do a clear screen and do a pwd, I have a lot of scripting, and one of the directory that I prepare for you is demos. actually loops first, loop, and then demos. So clearing the screen, this directory. Inside this directory, I have a number of files, and as you can see, there's bash script and shell script and C shell script. So in order to demonstrate all of this scripting, let's just breaking down by start.c shell first, and then start.sh born shell, and start.born again shell bash. So these are the three type of shells, mainly the bash scripting born again shell, which is a superset of sh. C shell and true C shell is a C-like syntax. I'm going to demo that also. But the majority of people that I taught a class at Pasadena City College, Linux scripting was bash scripting. A lot of people either nowadays they develop bash scripting or ZSH scripting or through C shell or maybe Python. Python scripting is very, very common also. But on the operating system side, you usually write a set of shells, which is born shell or bash, that is all common there. You don't write Python or C to do some kind of build on the system, but if you are writing like an application or writing some tools for more than just a shell, then it's good to use Python for that purpose, or C and Go language in other words. So at this time, let's just get started with the first command, which we're gonna show you what is my shell currently. My current shell is bash, as you can see here. How do I know that one? If I say echo $shell, this environment variable is called bash. The environment variable shell that is called shell, it is pointing to /bin bash. And how does it know that one is for this ID-UN? If I say, okay, I'm logged on as wlutfi, if I say get end password wlutfi, it tells me that I am using a bin bash. And how do I know that is actually there? I could do the same command here and say grep -i and then $shell. $shell. If I just do that one, it will show that there is a bin bash is that current shell. I can also use this command here. I could do backtick ID-UN, the same command that I did earlier. ID-UN is going to show that one with the information that is there. Clear the screen here, and then if I do, this is just ID-UN for all of the user, and then if I just do ID- let's try this command, say wlutfi here, or you could try also $ID-UN here. And then I could also say if I want to just get only wlutfi, I could do a grep wlutfi here. So that would just minimize showing other accounts as well. So this is, you can restrict it with that command. And if you do the backtick here, the backtick equivalent to that one would be this. And instead of the $, and then left parentheses, right parentheses, you could do backtick, it will just do the same thing. So now we know our shell. Let's go back to the browser and show you what I already have for you on my MyWebUniversity website. MyWebUniversity.com is my main page. If you go to the actual secure page, MyWebUniversity.com, I have posted some of the videos as well as some of the classes so that I provided. Here is the table of contents for the main book that I wrote, The Direct Path to Linux Ubuntu. And one of the chapter, as you can see, chapter 5, Chapter 5 is basically the Unix and Linux shell scripting on that one. This is a very good book. There's thousands of PDF files on 6,500 PDF files on Linux, manual pages on chapter 8 that I wrote in Python that generated all of them in PDF. And then similarly about 2,000 for the C and C+ header files. And then all of this is scripting that I did on it. Some of them are wrote it in Python and the actual main program. Then this web page that I just generated, the index.html file, I wrote it in shell scripting, Unix shell scripting, that generate all of this online there. So there's a lot of stuff that you could just get it. In each one of them that you click, you get the output in a PDF format for that one. All of that one, I had to write a shell script to read about 6,600 PDF files, depending on the extension, and then it will just open it up and there properly, and then make sure the format, the color, and all of that generated is in shell scripting. This is shell scripting. The actual PDF file was written in Python. So I'll show you this one, as well as I want to show you chapter 5. Chapter 5, which is Unix shell scripting. I wrote this chapter for a number of reasons. Long time ago, I wanted to just give you instruction on some of the scripting. For example, the for statement, you would actually see the exact source code here, the shell scripting. And if you just want to cat it, it will just show you on the Unix syntax here, the actual script. And if you run it for each statement, it will give you the output on the web. And if you want to just run the script here, you can run it also. And here you can also type in command like uname-a. You will just get the operating system that is there. If you just say cat etc os-release, you could do that one, as well as you could just come back here and then just do the comparison. So if argument like this one is for comparing the two statements, and this is the cat for that script, you can look at all of this. I'm just going through fast through them because I will show you actually on the Linux server, on Ubuntu in this case. So this is the GUI interface that's available for your practice. You can practice it and you can run the commands as I showed you, as well as run all of them. So if you look at the if statement here, you see if statement, the value of 5 is there. So 5 is smaller than 10. How do I know that one? Because here on the actual script, it just says that value 1 is 5, value 2 is 10. Then it does a if statement and it compares them, and then whichever one is smaller, it prints that output there. So this is the shell scripting. For each of the shell scripting, I also made these videos available for you, covering the while loop, the for loop, the for each loop. So let me make this screen a little bit bigger. And as you can see, learning Linux, I made the while loop here, this video that will just teach you how to use the while loop. And this is the for each loop. This is the for statement. This is the nested statement. Please watch these videos and you will learn all of the things that you need to learn about shell scripting. The if statement and nested if statement, the environment variables, how to set up the environment variables, if statement here, and then bash, awk, and zsh, all kind of shell scripting are compared. This video shows you the awk programming language, doing the hello world there, and then maybe C and C++. A lot of different languages I have done it. This one is shell scripting, writing functions, and then writing shell script function scope of local and global variables, and then Python tips and tricks. And then here, this one is get any Linux command manual pages. This is also done on for the manual pages that I just did that one. Hello World program in Bash and Python and C, and then Python tips and tricks. So for example, this get any Linux commands. This is another video that you could watch here, or just go to the main page again for the main page and go to the table of contents here, table of contents, and then this chapter where it says Linux manual pages in PDF format I showed you. Then you can also do manual pages for any commands that you are looking for in HTML format. This one, you could just type in the command here. This I wrote it in a combination of Python, shell script, and other ones. So you can type in any command you want to do. Like if you want to say print working directory, show me that one, it will show you that one. If you say show me the systemctl command, it will show you that one. And then if you say show me firewall D, it will show you the firewall D. If a firewall, maybe firewall is not actually command, so it's a firewall is the D is the daemon, but firewall dash cmd is the command that you want to do for. This is Ubuntu. So Ubuntu does not have its Ubuntu firewall. That's UFW. And Linux is firewall D and stuff. So when you're looking for the manual pages on Ubuntu, you have to look for Ubuntu firewall D. And then if you're looking for system, and then look at the bottom here on the firewall D, on the man pages, if there's any other section that shows you see also section, you can just go to the bottom of it. It's a lot of commands here. Let me just go all the way to the bottom, and for some reason this screen is a little bit hideous. Yeah, it moved it all the way there. So now you can see like IP tables, IP sex tables, and IP table restore and other ones. They're all kind of option for firewall D that is also on Ubuntu. And then FW framework, dash framework. You can also search for that one. So if I just say UFW framework, that would give you the UFW framework here. And then for IP tables, obviously, IP tables is there, and then IP table dash restore and IP table dash save, and all of that one are there also. IP table dash store. I mistyped it with one character, I believe. So IP tables. If you look at the IP tables section here on the manual pages, yeah, IP tables and dash restore is there, dash save, not dash store, dash restore. That's why I mistyped it. Dash save is to save the IP table. IP tables dash restore is to restore the content of it, and that give you the IP tables. So in order to just look for firewall, you look for Ubuntu firewall on this page, and then that would give you all the information about Ubuntu firewall, the commands here. So let's go back to the command line on the Linux side, and we're going to start up the practicing the commands. So let's do this. I'm going to log in first. As you can see, my host name is this. I have come through SSH. So if I say who am I, it's gonna say I'm W Lutfi, and ID is showing that one. If I say who space MI, it's gonna show the shell, the IP address that I logged in from through SSH. So PS minus EF A grep minus I SSH. You can see that one of the session I'm coming through SSHD and then connecting to the server. So if I say sudo su dash ls, no, not sudo lsof, and then grep minus I stitch itself, you can see that it is gonna give me information if I type in the password correctly, and then you can see all of the SSH here that are coming. And then one of them is my connection. As you can see here, clear the screen, who am I? I'm showing you that one, and then if I up arrow this command and then do a grep minus I W Lutfi, then you can see all the W Lutfi connection that is established through that port through SSH, it is coming here. Okay, and so we can clear the screen. That means I'm not on the local machine, I'm on a remote machine, and the host name is on that one is www.mywebuniversity.com, etc os-release is Red Hat Ubuntu. But if I go back to this menu where this is clear screen here and exit out, notice that this machine is called MyWebUniversity, not mywebuniversity.com. etc os-release of this one is saying Ubuntu 22.04.2, where this one is 22.04.5. So that is a different machine. And then also how I know this one, because on this machine I'm logged on with a different user. So this is the machine that I'm logged on. Here I'm logged on as different user, and then you can see that is that information. If I run top here, you see all the commands here, and then if I run top here, that I'm running a web server here also, and grep minus I HTTP. You actually Apache. Apache is running, so that is the process, and that are they are here. It's not running Apache. So at this time, I'm going to show you first very short script that you're writing in Linux Ubuntu. So when you're writing a bash script, if you look at PS as bash, so if I want to just open another bash, I could just type in bash again here. And then now I have two bash echo, and the second one is pointing to 6182. So I'm going to just exit out of that one and I say echo $$. It is now pointing to my main bash. If I exit out of this one, this bash will be terminated. I can just spawn another shell here and then do a PS. Now echo $$ is to a Bourne shell. And if I just exit out of this one, clearing this screen PS, and then I go to C shell, now my C shell, the prompt change also, echo $$, it is C shell prompt. Obviously, the syntax of this one, if I say set env x1, now echo $x is set to 1. And if I just want to set env name is Wahid, then now I echo $name, it is Wahid. But echo $ uppercase name is not defined. So I could say exit out of this one. Let's say I go back here on the bash. Now I say echo $x. It is not defined because I'm on a different shell now. I have to do export x is equal 1, and then now say echo $x. It will tell me that's 1. export name is equal Wahid, then echo $name. Now that is defined. But let's just clear the screen here and then just type in a couple of commands here. So if I want to run my shell, by default, every shell echo $shell that you're using has on your current directory, print working directory, there's a dot bash or C based on my echo $shell. It is dot bash or C, meaning that this dot means it's a hidden file, bash is the shell, and RC run control. So if I just run my dot bash or C, let's say I do export PS1 is equal $. I change the $. Now I just do echo $PS1. It is just what I said it here. So if I want to just not give the space here and give the space here, then now my prompt is corrected with that information. Echo $, is showing that is my prompt. And if I want to just add something to it, I could do that. But let's just look at this script, dot bash or C. And at this time, I don't have anything on it. I'm going to just say, go ahead, run this one. And notice that as soon as I run, it changed my prompt. Why did it change my prompt? Because grep ps1 is equal from the bash or C. It will tell me that whenever I run the bash or C, just set the environment variable to this. And echo $ps1 now is set to that value that we set it here. So at this time, if you see the /u meaning as user, and then at the host name, /h the host name here, and then tell the current directory is pwd or pwd or echo $ print working directory. That's the same thing. So if I just change my shell again, and let's say I change it to, excuse me for a second. Sorry about that. There was a sneeze that I had to stop the video for a second. So let me just go $, and then space here. Notice I changed my shell here. So now if I just do any command, host name, clear screen host name, and then ID, whatever command, calendar, I can run it and my prompt will not change. But the minute I say what is my current directory, I run the bash or C, notice my prompt changed to that, because echo $ PS1 is again pointing to the shell that I wanted to set. So that is one advantage with this .bash or C. And so clearing the screen here, if I say aliases, the list of aliases that are there, you don't see any Python alias or anything, right? So if I say here, say Python 3 -- version, I could get that information in our Python -- version. I could, clear screen. And let me just do aliases first. Python -- version. It just says Python is not recognized. In order for me to have an alias, because Python 3 is there, but Python itself is not pointing to anything. So I could create an alias, say Python, and then is equal Python 3. Now, if I say the up arrow on this command again, it will show Python is version. I could just make this Python 3 an alias just for Py. So now I type in Py, it will just run the running Python 3. And that is similar to that. And if I just go quit out of that one, quit with the parentheses, so you could do as a function. Aliases, and notice when I type in alias and alias Python, it's pointing to Python 3, and then alias Python Py itself is also pointing to Python 3. So why is one giving you it should do the same thing here. The one that you want to do is, rather than do that one, say alias py v for Python version is equal, and then we could just say Python dash dash version. Now if I just say alias py, you see alias Python and then alias py v. So clear screen here, alias py v is there, so py v Python version, it will just give you that. And then if you just say alias all together, it is all set. But notice that if I just run .bash or c again, as soon as I run that .bash or c, now alias is going to be shorter. It actually is transported with that one as well. So I could also go on vim and then bash or c. Since I have the ownership to modify it, I could say go ahead to my aliases, and then on the aliases I come in here. So on the aliases, I could just add another alias here on this list, and then I'm going to say alias Python is equal, and then put Python 3 here. I could even put the version user bin Python there, that would also work, but since Python 3 was recognized, then when I say Python 3 dash dash version, it works there. Python 3 dash dash version, I must type it again. So right here, if I just look at the aliases here, the Python dash dash version and PyV, I'm going to exit out of this window and open a new window here. And then just by opening a new window, I'm still on the same machine, and my echo $P is 1 is still pointing to the right one. So if I cd to dot dot and then I do a pwd, I'm on my current working directory here. And if I just say aliases, alias command, you can see the only alias that is now available, PyV is not there, but Python is there because I put it inside the .bash or C. So if I look at the grep -i alias on the bash or C, aside from all other ones, I put this one there. And if I do a grep -in with the line number, you can see on line number 85, I have that alias Python. So that means that I can type in now Python to get into Python, exit out of this, and I could type in Python -v version. It will give me that, or Python -v uppercase will give me that information. And then there, all these tools are available at this time. So let's get back to writing a shell script. If I'm on this current directory, we just showed you the .bash or C, which is etc ls -l etc profile is also a configuration for your profile that you could just set, or .bash or C based on your shell that you could have those ones. So inside of etc profile, there's a number of systems, F statement, var statement that are all written in shell scripting, born compatible shell script. And then at the same time, more .bash or C is just shell scripting. So there's case statement, for statement, if statement, on some of those options, all of them based on the history that you do, all of that one or there with the coloring, all this information gets set here for you. So if you're writing a customized script here, let's say I make a CD to programs. I don't have a programs directory. I'm gonna make a directory called programs, and then go to programs and make directory shells. So now I'm on the CD2 shells, and I want to just write a simple shell script to say something like let's say vim new $1 and if you say pound shebang user ben env bash, if I want to write it in bash and say for example echo $$, and then just say id-un pwd who am I, calendar command, date command, just to show you a number of things without any if statement or any further statement. So now I have created this new $1, and then on this one I want to change my prompt so it doesn't have to show all these details at one shot. I'm going to say export ps1 is equal $, and then a space that. Now I'm on this directory and the file script is new $1. Notice the permissions is not readable. So in order for me to execute that command, cat -n a new $1, all of these lines can only execute if I say bash -x new $1. -x means run it in debug mode. It runs each command and then it shows the output below it. So you can see the echo $$ was giving you this output, and then id-un give you that output, and pwd give you that output, and so on. All of that, including the date command, which was the last command, and outputted this. But if you don't want to see that option there, then this new $1 is you have to change the permissions. So say change mode plus X new $1. Now new $1 has execute permission set for all of that user, owner, and group. So now I can say new $1, and notice the color also changed. So now this time cat new $1 is this script, new $1 output is that. So for each of the command that I did, the output is shown below there. And then at this time, I could also capture the output of this script to another file. So let's say I say script here, let's say new $1.out. So I could just say run that one, and then at the start of the script, my shell prompt change. So I'm going to say new $1, run it. It outputted and exit out. Now I have a file called new $1.out also. In addition to written to the screen for a new $1, cat -n new $1.out has the same output for all of those commands that was run. Okay, so that's the script command that captured the information. But let's just get out of this environment. I'm not going to use this one. I'm going to be on my host name, which is the Unix web server. The Unix web server, which is I'm logged on remotely, as you can see, it is there. So I'm going to go to this directory where I have already been here. And earlier I showed you that I have some C shell script, but notice my prompt is still bash. So $shells, it is there. Also, there's a file cat etc shells, as all the supported shells that are on this machine will be there. So whether I could write it on dash, bash, or bash, 2max, and then screen, all those other commands are also supported, but Tmax is actually for just doing similar to screen multiple multiplexer terminal multiplexer. Through C shell is a superset of C shell. Bash is a superset of corn shell and Bourne shell. SH is Bourne shell and corn shell is KSH. Dash is Debian. Let me just do man dash. I think is the standard interpreter for system, the current version of the process. It is, I think, it's stand for Debian bash, Debian shell. And then there's R bash, which is restricted bash. Man or bash. Yeah, restricted bash. That's what it is. And the Z such is not in here, but you can install it. So man ZSH, if I do that one, it's not there. And the way you do install it, you become sudo here. Sudo is u dash, and then type in the password. So this time, let's say which ZSH is not there. I have to do apt install ZSH, and that's a Z shell. And once you install it, and then at this time you can get into ZSH shell. And then if I want to change my prompt from bash to ZSH, I could do that one by modifying my shell, default shell. And at this time, I'm just showing you this shell is also available, which is ZSH. So PS here, cat etc shells, now ZSH is there because I installed it, it is available. So now if I say PS here, if I want to go to ZSH, it is changing my prompt, and notice that I'm on ZSH echo $, and host name PWD current working directory of root. Here, if I just say, let's do a for statement for I in sequence of 10, and do echo $I, and done. And then at this time, if I just say sequence of 10, notice that clear screen sequence of 10 is not going to just generate the same way that the for statement should have done. So that one, I have to put this one in a backtick to run that code in order to get that same output. Or I could do it with subset command $, subshell command, and then you could do that one. So those are some examples of ZSH. I'm going to exit out of this one. Now I'm on C shell. I'm going to get out of root. I don't have to remove the ZSH. I will later on change the shell from bash to ZSH. There's a lot of neat stuff that with ZSH also that I like. So here I'm going to show you some of the shells. So since I'm on the bash, in order for me to execute some of these shell script, like if I look at the for each .csh, it says that the first environment that you run, it should run this environment, the binary, and then load the through C shell interpreter. And then these are common, and then the rest of the statement is a for each statement with these sports, and then also a for each statement with character, and a for each statement with number of fruits there. So if I just want to run that script, and instead of catting it, I could say / do this, and it will execute that one, even though my shell is bash. So if I just do this one and then run it that way, I could do that one. I could also say C shell -C and then run the command, but I have to say from the current directory here, and that would also run it there. But since I have already put the first line, I don't need to say what shell I am there, because head minus one for each .c shell, it tells you that this shebang user ben env is going to look at this environment and then finds the true C shell. So which true C shell is actually get loaded as interpreter for it, and which env is going to run that user bean. It is like saying that shebang user ben C shell. That is this one is equivalent to that, but this one is more dynamic. This is better way to do it than just having hard coded with the C shell. So don't hard code it. That's why I'm not going to modify it. Having this one, if you're running bash, it's gonna look for bash. If you're running Python, it's gonna look for Python. If you're running C shell, it's gonna run for C shell. This environment is gonna just look for the interpreter that you want to use. Perl, Python, C shell, bash, corn shell, sh, bourne shell, zsh, any of them, you just pass it on as that one. And then the environment variable, the file user ben env, and that's an executable binary. It will find the interpreter there that it will just tell you how to load it. So the store.c shell, let's just vim this file for each .c shell. I'm going to run the first for statement and comment the other two. So we get a smaller output here for these two. In order to not run these ones, you have to comment it out. And then to comment it out, you put the pound sign in front of every executable command that's supposed to run. So, and the for each statement starts with for each, and then it has an end statement. So I'm going to comment them out and then run it one at a time. So now say cat for each .c shell. Only these commands will run, and nothing else. They're all commented out. Everything else is commented out. So if I just say grep minus v and verbose, and then say show me everything but the line that are commented out, then it shows that those ones that are here that is not commented out. So if I just run now for each .c shell, it should run the line for sports, football, and swimming, and it's giving me the output accordingly. Similarly, let's do the them for each .c shell again. This time I'm going to comment this one line out and uncomment this line out for each these three lines. And now I'm going to clear a screen here and then run the same command of the pound. This is the only line that's supposed to be running. So when I run it, notice that it's going to say the character A through E or A through F with uppercase and lowercase, as well as the numbers are going to be printed. Similarly, I'm going to modify the script here, vim this, and then let's just comment this line out, and this line out, and this line out, and then just take the last one, which are fruits, and then clear the screen here. This time, if I do the same command, only the fruits are going to show. And if I run it, it's going to show apple, banana, grape, orange, and pear. So that's how easy it is to write the program. And if you want all of them to be written, you have to do a VI here, uncomment this section, that section, like original script was, and then have it there. And now clearing the screen. Now, if I do this script, it's going to just show all of those three loops for each loop and statement. And running it, it's going to do more than just one screen. So you have to move up to look at the top of the list. and right there is the for each statement, and last part. So clear screen, and let's start on the C shell. Now run the f.c shell. F.c shell, it is just doing a number of things, so more f.c shell. And this one is doing all the for statement, but at the same time, it is doing some comparison of fruit is banana, write something, and if it is the character is D, or this is an or statement, whether it's character is uppercase D or lowercase d, or character is 5, then print I'm interested in either D or D this. So this is a if statement within a for statement. This is a if statement that if sport is soccer, then it says I love playing soccer. So you can do a lot of stuff here, as well as on the fruits. If the fruit is banana, did you know banana is called Kela in Afghanistan, and for C language? So let's just look at that one. Clear screen, f.c shell. And you can see all of those numbers that were matched. It did those if statement that were there, and then also here. And then when the sport was, let's see, the character is D. I know apple and banana. Yeah, and for soccer, the first one, I love playing soccer. It matched that one also. Otherwise, it give you the sports there. So the output of those ones are there shown here. And now I'm going to show you what is on the shell scripts that we have. So sometimes you have to automate your system. This example that I did for my Google ad banners, like for example, if you go to MyWebUniversity.com, on the top site where you are seeing the actual page, there's a lot of Google banners also shows up on the site. Maybe I comment them, some of them, but some of them are not commented. So when you go to those ones, you will see some banners, and maybe I just kind of disabled them for a little bit, or maybe not. But I'll have to look at the banners there, and then let me just look at one section here on the Linux chapter 7 manual pages. Yeah, so looks like I have commented them out, and the way I did it is through some of these automation scripts. So all the pages that are there, I just have to write this flex header and Google ads, and then either comment them or allow them. So if you look at the flex underscore head, I'm going to just quickly show you. So you set some string, and then eventually you look for those string and change it. And this is changing certain things. This is all programmed there, and it will tell you what lines and what script I modified it. I've done a lot of these things in there. It is gonna just be good for your tools that you want to do. And this frarc.h cat f-arc.sh, this is a shell script that it does comparison of some numbers between 10 and 5, and if they're the same, it's gonna give you the same thing. Otherwise, if you don't provide any argument, it's gonna give you a usage f-arcs usage. And for example, right here, this usage that calls in the function usage, it goes to the function usage, and it's just check and to make sure that 2 arguments, value 1 and value 2, is given. If not value 1 and value 2, it calls the subroutine, and then call the usage function, and the usage function returns this output here. But if I just say 10 and 5 here, you will get that value 10 is greater than 5. If you say 10 and 55, 10 is smaller than 55. And if you say 10 and 10, it will just do this one. That the 10 and other numbers is your choice. You don't have to always do the same thing. So whatever number you do, you could just make it. Let's say I make a bigger number there. That number is going to show output accordingly. So the script is dynamic here. Let's $h here. Clear the screen. $h. And let's do the if else statement. We could say f-else statement $h. If else statement $h, and then see the value of this is equal to the value of this. So we did not give the value, and then the script is not checking for any of that one. So if you say why is that one, let's look at it and say f-else, and then here you can see $1 was given as argument, $2, but there's no comparison of usage on this script that if it is not provided, those values should complain. That's why I wrote that usage. And this one was when you are not writing a usage function to say how to check for those ones, and you're just looking for this one. When you don't give an argument here, you just don't get any output. If you don't do this correctly, like this one does not give you, but if you say 10 and 20, it will give 29, it will give you the output, since those values are not there. That's why this other statement that it's there, I wrote this f-args with the argument. So you don't specify, it tells you the syntax that is there. And I already showed you that 10 and 29 would still work, but the only difference between the else statement, it does not have a usage function calls. To see that arguments are missed, you have to ask for it. Say, this is how you run that script. So that is one example. Then if a smaller number, if that's a smaller number, this one is also comparison between them, and it's one is smaller, it's going to check it. If it is bigger, it's going to show bigger, and if it is equal, it's going to show equal. And now I'm going to show you this other script called welcome.sh. So cat welcome.sh. This welcome.sh and just welcome you to my YouTube channel, which is MyWebUniversity, and then it's gonna just go through a for statement between 1 and 10. This for statement is a sequence of 1 to 10, and it's going to just look if the number module 2 and remainder is 0, then it just change the color to certain things for that one, and if otherwise, it's gonna set up the color and actually put the text in white text, otherwise it's going to write it in a color text. This laugh out loud cat. So if I say there's a script name here, cat here, you could see cat here is there, but if I say laugh out loud cat, it will just change it in color. So otherwise you just get it in clear text. White text. So let's just run clear the screen here. Welcome.sh. So that script runs the welcome to my YouTube channel, which is MyWebUniversity.com, with these asterisks around it, and then about 10 times. And notice that since the numbers are even, it always printed in white colors. Otherwise, with the laugh out loud, depending on the color scheme that's available, it generates these ones. So every time you run the script, you get a different set of colors for the odd numbers, and then for the even numbers, you're gonna have white colors. For odd numbers, is always a different color. You can see. Okay, so that is for that script. Let's look at the bash script, what I have for you in bash script. So on the bash script, I have a lot of script. I'm not going to go through all of them because there's a lot of these videos that I showed you on chapter 5. I have already covered a lot of these videos here extensively for each one of them, and that are maybe 20 minutes to an hour to an hour and a half hours long. But I could show you, for example, just to cat all of these scripts in a short form. I could say, for example, let's do a cat minus n while star.bash. This one, cat minus n, is going to go through each one of them while 1, while 2. So I don't have to do it 5 times. It's going to just open each one of them. And then you can see from the line 1 here, it is going there, then it goes to the next one, and then it does that one, and so on. All of that one. You can also write a one-line script here and say star.bash, and then I could say, show me that one, or just say while star.bash will just show me those. And then I say, if I want to just get this file name, I could say awk and then print a $9. That will just give me the name of the files. And then I could say while read and then var for variable, do say, I'm going to do a date here, timestamp, and say echo checking on $var now. So notice I go here and I say cat minus n while underscore demo1.sh. And then here says sleep 2 seconds and then done. So now it says checking on this. So the file says no such file or directory, because when I say checking cat minus n, I still did the while demo there. So let me clear the screen and go back to this statement, see what I wrote here. Right here, I wrote the while demo incorrectly. I meant to say just $var, print that one. So now it's going to work. Earlier, I had the typo on the while anyway, but I meant to replace it into the file name. And if you just want to run it, obviously, if the script has some argument, you have to pass in the right argument. So while underscore demo1.sh, let me just see, while start, okay, while underscore demo1.bash, not the .sh. So you can see that the script runs with this information, and cat minus n while demo1.bash has that information, saying that while a statement it starts from 0 to num max, and it prints out all of the variables here. Clearing the screen, let's do the number 2. And number 2 is also doing some statistic as well as a stat on it. So while underscore demo2.bash, this one is saying that give me the file name. If the file doesn't exist, then just print out an exit. If the file exists, then just go through and do a stat on it, and then also run the for statement there. So doing that one again, and just running the output here. Since while demo 2 exists, it does a stat on it, and then which is this command right here, stat on it, and then for a statement with the else part, and then run the while demo at the one.bash at the end of it, and there. So let's look at the bash. So clear screen cat minus n while demo3.bash. Again, some of these scripts I'm not going to run all of them. It is very similar, and the only one is sometimes I just want to display, sometimes I want to get a different output when its file is missing. So like this one, if the file is missing, when you run it, what does it say? Missing. It says the file missing. If the file that I was looking for was not there, it exits out and it doesn't run it. So the file number 4, demo 4, might be a different one. Yeah, file demo 4, it is looking for a directory that when the output of the command is not passed on correctly. And so it is saying that this is a directory. Now, if I just want to do the better one, I do file demo 5, it is going to just run that script. So notice more while underscore demo 4.bash does not have that checking to see if the file this $2 $3 is provided. So that's why $2 is saying from the current directory it is there, and then when you do that $5, that $5, it's going to give you usage, and more while underscore demo 5.bash, it is going to check if it the number of argument is not passed it correctly. It's going to run this, then exits out. The bash underscore while underscore demo 4 did not have this line that I marked it here. This checking is not there, so it automatically already checks these ones, and that's why it gives you that dot stuff, which is the current directory. So we covered this, and then let's just see on the bash some more statement, the for C shell syntax. So I'm going to do a for C syntax and dot bash, and that's also there. And then if I want to look at the content of this one, similar to the other statement, it runs all these for statement. This is like C-like syntax for I statement. I is equal less than 0. This syntax is much like C, C++, Java, JavaScript, other ones, except on the bash you have double less than sign and double close than sign, and then on the braces on the Java and JavaScript and C shell and C and bash, C and C++, but do and done on bash, and that kind of syntax. So this is all similar here. The for this one, when the variable, you don't have to reuse a variable here. So for I in sequence of 5, it's just going to print those numbers, and it's going to just, you're not just saying print I, it just print out new line characters there. And then let's see what other thing that C shell, we already looked at this one, dot bash. And then sequence argument for sequence or arg.bash. This one is a very simple example for sequence dash arg.bash. This one is basically saying missing operand. Since we did not give the operand, $1 is here. You could say 10. It will print 10 numbers. You will say 5. It will do 5. You do 1,000 numbers. It's going to do all that. Start.bash, and then for sequence sequence dash steps dot bash. That one is just stepping between the numbers, and then here the example is 30-5. So 3510. If you just run that one with this example, it has a start and how much it steps through and how much it's going to end it there. So that is between those step through. Clear the screen. Start.bash. Okay, the next one that I'm going to cover is for sequence.bash .for dash sequence.bash, and then cat it, and you can cat -n dot slash, dot slash from the current one. You can see the for sequence of 3, do the number values, and when you run it, it just give you that output accordingly. And then what else is there? Dot bash. Okay, for sports dot bash, clear screen cat minus n for sports dot bash. This is gonna be the last one because I'm gonna go play soccer. And you guys have a great time. I hope you enjoyed it, and I will hope you're gonna just subscribe to our channel so we can bring you more based on your needs. And then as you can see, this one is just running a for statement, where the first one does not have a defined item and sequence, so it brings 3 lines of blank space first, then it goes for sports to the list, and then it says great choice if sport is soccer. Otherwise, it just says sport is also one of my favorite sport, and then prints 5 new lines, and then exits out. So that's how it is. Great choice. I also love to play soccer. Football is also one of my favorite sports. Volleyball is also one of my favorite sports, basketball, swimming, running. In fact, all of these are my favorite sport, especially soccer. But I'm sure that you have a lot of other sports that you like better than soccer or better than other sports. Everyone has their preferences, and I value your preferences as well. And I hope you do the same. Take care. God bless you all. And please don't forget to join our channel. For all the videos that I made, I still don't have enough subscription. And I hope that like every other ones that are more than 100,000, at some point mine also gets there. But at this time, I am not happy with that subscription. Please make sure that if you're watching the videos, tell your friends and co-workers, everything, that all these videos are for them. They need to subscribe and enjoy and start learning and educate themselves, help themselves and their families and friends and loved ones. God bless you all. Bye. Have a good one.